Okay, let's start. Uh, in last session, we were discuss about how to develop an ER diagram for a given scenario and how you can map the ER diagram into database schema. So today we are going to discuss about mapping ER diagram into relational schema. This session is not available in your book, but this is very important. You have some idea about the relational schema and you have some ability to map in ER diagram to the relational schema before moving into the data table and the normalization. So let's discuss about this one. This is not available in your book. Okay. Before that, can you all hear me clearly?
Yes, madam.
Yes, madam.
Okay. So when mapping an ER diagram into a relational schema, first of all, let's discuss about how to map a strong entity in a relational, how to map a strong entity in ER diagram into a relational schema. We discuss about relational schema uh, by using a Microsoft Access, but this is the formal way of mapping ER diagram into a relational schema. First, let's discuss about how to map a strong entity into a relational schema. You can see, so every regular entities in ER diagram is transformed into a relational schema and the name is given in the relation is generally the same as the entity type. As an example, let's take this entity. This is student entity and there are some, this is course entity. So when mapping student entity into the relational schema, you can use the same name like this. This is student. So, and also when consider about the entities in the ER diagram, you can see ER diagram is consist with entities, then the relationship types and the attributes. So each simple attributes of the entity types become an attributes of the relation schema. There are some background noises. I'm going to mute you all. Okay, so you can see when consider about ER diagram is consist with entities and the relations and the relationship type. So it's relationship types and the attributes. So when converting this ER diagram into a relational schema, you can directly use the same name with the attributes. So that means each simple attributes in the entity types become the attributes of your relation schema. And also you can have primary keys in the corresponding relations according to the ER diagram. Okay, you can see this is the one entity in your ER diagram. You can represent this like this also, customer, then the customer ID. This is the primary key, then the customer name, then the customer address and the postal code. So these are the attributes available in the customer entity. You can see customer ID is a primary key of this customer entity. So now we are going to convert this ER diagram into a relation schema. So we can create a relation schema by using this name. Let's take this relation as a customer relation. So this customer relation is consist with 1, 2, 3, 4 attributes. The first one is customer ID, then the next one is customer name, then the next one, customer address, and the last one is customer code. You can represent the primary key by underlining this attribute. So this is the primary key. You can underline the primary key. So this is the corresponding relations to this ER entity. Okay. So this is a strong entity. So we can convert this strong entity to a relation schema like this. Okay, so this relation schema can be named as customer because this is a customer entity. You can represent primary key by underlying the attribute. Okay, is it clear?
Yes, madam.
Okay, then let's discuss about composite attributes. So when mapping these attributes, you can see all these are, okay, before that, these are simple attributes, no composite attributes available in this entity. So now we are going to map composite attributes into a relation schema. So you can see this is a strong entity available in ER diagram. So this strong entity is consist with customer ID, then the customer name, then the customer address and the postal code. When considering about customer address, it is a composite attributes. That means you can further subdivide this entity into another, these attributes into another subdivided attribute. So you can see this address can be subdivided into street, then the city and the state. So when mapping this entity into a customer relations, you can see the customer ID, then the customer name. You need to use the simple attributes. So the street, city, state are the simple attributes. So you can convert these composite attributes like this. And the next one is postal code. So when a regular entity has a composite attributes, only the simple components of the attributes of the composite attributes are included in the new relation schema. So when you are mapping a composite attributes from ER diagram into a relation schema, that means relational schema, you can include the simple component attributes available in the composite attribute. Okay. This is about strong entity. These attributes are simple attributes. You can directly map the simple attributes into a relation schema. But when we consider about composite attributes, you can map simple component attributes of the composite attributes into a relation schema. Then the next one is about multi-value attributes. So you can see when a regular entity type contains a multi-value attribute, you need to create the two relation schema. Keep in mind, if your ER diagram is consist with multi-value attribute, you need to create two relation schema for this multi-value attributes. Okay, the first relation schema contain all the attributes of the entity that accept the multi-value attribute. As an example, let's take a student entity. When consider about a student entity, you can see, you can see student ID, then the student name and the student address and telephone number. The telephone number is a multi-value attribute. So when you are mapping this student entity into a relational schema, first you can map one relation as a student. In this relation, you can include all the attributes except this multi-value attribute. And the next relation, you can include this multi-value attribute with the primary key of this entity. So let's take an example. So this is about employee ERD. That means this is a strong entity. This is about employee. You can see employee ID, employee name, and the employee address. When consider about skill, it's a multi-value attribute. So when converting this ER entity into a relation schema, you can see you need to create two relations because one multi-value attributes are available in this entity. So you can create first relation as an employee. You can include employee ID, employee name, and the employee address as the attributes of this relation. Then you can create another relation by using the primary key of this entity and the multi-value attribute. So you can see employee ID and the skill. So these two get together to form a composite key. Employee ID, this is belongs to this relation. So this is act as a foreign key in this table, and these two get together to form the primary key of this relation. Okay, so keep in mind, if you have the multi-value attributes in your ER diagram, you need to create two relations for that entity. So one relation is consist with the attributes except the multi-value attribute. The other relation is consist with employee ID, that means the primary key and with the multi-value attribute. Okay. So you can name it as a employee skills, because this is came from the employee and the skill is the multi-value attributes. By using these two, we can give a name as a employee skills for this relation. So this is all about a strong entity. So in consider about a strong entity, you can map the simple attributes as it is available in the ER diagram, then the composite attributes. So in the composite attributes, you need to map the single, that means simple components of the composite attributes into a relation schema. When we consider about multi-value attributes, you need to create two relations corresponding to the attributes available in the entity. So all these are about strong entity. Let's discuss about weak entities. So let's discuss about how to map in a weak entity into a relation schema. Wait, there is a question, ma'am, how we show the derived attributes in this mapping. So like this, you can create the relation schema like this, okay? Then let's discuss about the mapping weak entities. So when we consider about weak entity, I think you have some idea about weak entity. So what is meant by weak entity? Can someone answer my question? What is meant by weak entity?
It should be existence dependent.
Yeah.
And the primary key partially or fully derived from the parent entity.
Okay, so you can say weak entities totally depend on the strong entity of that relationship. So this weak entity does not have a complete identifier, but must have an attribute called the partial attribute, partially identifier, that permits the distincting the various occurrence of the weak entity for each owner entity instance. So no need to go through the weak entity again and again. Let's see how to map employee, that means how to map weak entity into a relational schema. So the weak entity is totally depend on other, that means the strong entity of that relation. So you can see this is the employee ID. This is the relationship. Employee claims the dependent. You can see this is a strong entity. This is a weak entity. When we are mapping weak entity into in a ER diagram, you use double rectangle to indicate the weak entity. So the dependent is a weak entity, and this entity is totally dependent on this strong entity. So when you are mapping this strong entity, you can map it like this: employee ID and the employee name. This is the relation. Employee is the relation name. You can map it map as employee ID, and you can underline the employee ID, this is the primary key, then the employee name. So when consider about dependent, this is a weak entity. So you can map this into a relation with the name of dependent. You can see first name, middle name, last name. This is a composite attribute. So these are the simple components of this composite attribute. You can take first name, middle name, last name, then date of birth and the genders. So these are the available attributes in this ER entity. But when we consider about this one, this is a weak entity. So we need to indicate the primary key of this strong entity in weak entity. So let's take this employee ID. This employee ID and these three attributes get together to form a primary key of this relation. So this is this has a reference to this employee table or an employee relation. So this is the way that you can map the weak entity in relation schema. Okay. Then let's move into mapping binary relationships. So when we consider about entity, you all know there are two types of entities: strong entity and the weak entity. Now we are going to discuss about the relationship. So when you are mapping a relationship into a relationships in ER into a relation schema, first of all, you need to consider about the types of the relationship. Relationship can be a unary relationship and the binary and the ternary. So, and also you can have some idea about cardinality of the relationship. So in this case, you can see one to many is, we already discussed about this. One to many is same as many to many, many to one. So this is the same relationship type. That means there are three types of relationship: one to one, one to many. Then the many to one is same as one to many, then many to many. So these are the relationship types. So these relationships are symmetric. Okay, then let's discuss about binary 1 to m relationship. So in this case, in 1 to m relationship, first you need to create a relation schema for each of two entities type participating in a relationship. Next, you need to include the primary key attribute of the entity on one side of the relationship as a foreign key in the relationship that is on the many side of the relationship. We already discussed about this when two entities are in one to many relationship. This is the one side, this is the m side. So the primary key of one side needed to be included as a foreign key of many sides. So let's discuss that with an example. You can see the customer and the order. When consider about these two entities, customer entity and the order entity, one customer can make many orders, so one to many relationship. So if you are going to map this relationship into a table, into a relation, you can take this entity customer. This is a strong entity. So you can create a relation as a customer, then customer ID, customer name, customer address, and the postal code. This is the one side. So this is the many side order. When consider about the order, you can see one and two. There are two attributes: order ID and the order date. Order ID is the primary key of this relation. So you can map this order ID and the order date as a relation, attributes. Then you can see this is the many side according to our previous rules and the ER rules. You all know you need to include the primary key of this side into this side. So we can include this foreign key as a customer ID, you can use dash line to indicate the foreign key. Then you can have the reference to this table. So when you are mapping one to M relationship, you can directly map all the attributes available in one side like this. But when you are mapping M side, that means many side into a relation, you need to include the that means you need to include the primary key of one side as the foreign key of this relation. Okay. Then about binary M2M relationship, that means many to many relationship. So in binary M2M relationship between two types, A and B, first create the new relation schema C. Then include the foreign key attributes in C in the primary key for each of two participant entity types A and B. These attributes become a primary key of a relation schema C. Then any non-key attributes that are associated with the end-to-end relationship between A and B are included in a relation schema C. You can see this is many-to-many relationship. If you have chance to map many-to-many relationship into a relation schema, first you need to create an entity, that means relation for this entity, employee entity. You can see employee ID, then the employee name and the birth date are the attributes available in this side. You can directly map these attributes into a relation. This relation is known as an employee. Employee ID is the primary key of this relation, then the employee name and the birth date. So this is the primary key. Then let's discuss about course entity. You can create a course entity as a relation. There are two entities, course ID and the course title. Then you can see this is the relationship complete. This is many-to-many relationship. So no, you need to create a new relationship. So this relationship is known as certificate. In this certificate relationship, you can include the primary key of this side and the primary key of this side and this relation attribute. So you can, I think you all remember this one, when you are having two entities in a M to N relationship, you decompose this into one to many relationship. Okay, like this composite entity. So you can map this composite attribute directly to a relation. So in this composite attribute, it is consist with this primary key, and if there are any attributes in this composite entity, you can directly map it into a relationship. Okay, you can see there are three relations available in many-to-many relationship. Okay, is it clear?
Yes, madam.
Ma'am, can you explain the certificate part?
Yeah, certificate part is, so if you are going to complete the course, so this is many-to-many relationship. So you need to convert this many-to-many relationship into a one-to-many relationship. At that time, I think you will remember, wait. So, wait. At that time, you all remember, I think this is the employee and this is the course. I'm going to create a new composite attributes. This is what many-to-many. So we need to decompose this into one-to-many relationship, two one-to-many relationship. At that time, we are going to convert this into one-to-many relationship with a composite attribute or a bridge attribute. Let's take this bridge attribute as a certificate. So the date complete is belongs to the relationship. So this is date completed is belongs to this composite attribute. So this is one to many and this is one to many. So when you are mapping this ER diagram into relation schema, you can directly map this employee ID and employee entity and the course entity. So when we consider about the certificate composite attribute, you need to include the primary key of this site as a employee ID, because this is a many site employee ID. This is the many site, so you need to include the primary key of this site, then the course ID. So this entity has its own entity, own attributes as a date complete. So you need to map these three in new relation. Is it clear now?
Yes, ma'am.
Okay. Then let's move into one-to-one relationship. We already discussed about one-to-many relationship, then many-to-many relationship. Now we are discussing about one-to-one relationship. So the process of mapping such relationship onto a relation schema requires two steps. So when you are mapping a one-to-one relationships into a relation schema, you need to follow two steps. The first one is two relations are created and one for each of them are participating entity type. So as an example, let's take this one. If you are mapping this into a relation schema, you need to create two relations according to the entities available in binary relationship. Okay, then the second one is, there are two steps now. The first step is you need to map the participating entity into a relation schema. Then the next one is the binary key of one of the relation is included as the foreign key in other relation. So when you are mapping one-to-one relationship into a relation schema, you need to indicate the primary key of one relation as a foreign key of another other relation. Okay, so then you can see this one. This is up to you. When you are consider about one-to-one relationship, you need to make a relation between these two tables. So you need to guess what is the primary key, what is the foreign key of, so what is the foreign key and which relation. That means you have an ability, you have a chance to select the foreign key. So this is one-to-one. So in this case, you can see this is a nurse. You can map this to a nurse relation. This is the care center. This is, you can directly map care center relation. So when we consider about nurse ID, this is the primary key of this one. Then the nurse name and the birthday, like this. Then this is the relation. Then when we consider about care center, you can see care ID, then the location and the date assigned. So you can take one of these. This is belongs to the relationship in charge. So this is a relationship schema, that means relationship attributes. So if you are mapping one-to-one relationship, you have a chance to select one of the ID as a foreign key of another table. So I'm going to take this one. So I'm going to include this nurse ID as a foreign key of this one, and this attributes is belongs to this entity. Okay, so when considering about one-to-one relationship, the association in one direction is nearly always an optional one, while the association is other direction is a mandatory. So you need to identify what is the mandatory one and what is the optional one. Okay, then you should include the relation on the optional side of the relationship for the foreign key of the entity or type that has the mandatory participant in one-to-one relationship. First, you need to identify what is the mandatory one and what is the optional one. Then you should include the foreign key according to this mandatory and the optional one. So this is up to you. You have an ability to identify which one is a optional one and which one is a mandatory one. So then you should include, that means you should include in the relation on the optional side of the relationship the foreign key of the entity that has a mandatory participation in one-to-one relationship. Any attributes associated with the relationship itself also include in the same relation as a foreign key. So these are the two main things you need. First one is you need to identify the mandatory and the optional one. Then you can include the relation on the optional side of the relationship, the foreign key of the entity type that has a mandatory participation in one-to-one relationship. After that, you can include the relation attributes for that relation. So can you identify what is the mandatory one and what is the optional entity? So what is the optional entity? Can you identify, consider this one. Can you identify what is the optional entity and what is the mandatory entity?
Nurse is an optional entity. Care center is mandatory.
Care entity is totally depend on this one. That means the care center is the mandatory one. This is the optional one. Okay. So when we consider about this care entity, you can include the nurse ID in this case as a foreign key of this entity, and this attributes also belongs to this relation. So nurse can be directly mapped as a nurse ID, nurse name, and the birth date. Then you can create another entity as a care center. So care center is consist with care ID, location, and the location. So when you are considering about the mandatory and the optional, you can include the primary key of this relation as a foreign key of this relation. Nurse ID can be taken as a nurse in charge. So this is the foreign key of this table, and you can include the data assigned. That means this relationship attributes belongs to this entity. Okay.
Ma'am, excuse me.
Okay.
Yeah, cash and the attribute, sorry, cash and the entity is an optional one or mandatory one?
When consider about, sorry,
Cash and the entity should be an optional entity, no, ma'am? Because we are adding the primary key of the mandatory one and the relational attribute.
when consider about,
We are actually adding those things in the optional side. So cash and the should be an optional one.
there is an optional one and the nurse is a mandatory one. Wait, give me 1 second. Okay. What is your problem, Puta? Who is
Yeah, actually here the care center entity,
is a optional entity, yeah.
and that's what I'm asking, ma'am. Before that, you said it's a mandatory one. That's right.
Okay, so when we consider about these two entities, you can see this is with the circle. So when you are representing ER diagrams, when you are representing optional and the mandatory relationships, mandatory entities in ER diagram, you use this circle to indicate the optional entity. So this is an optional entity. So you need to include the primary key of this mandatory entity in optional entity as a foreign key. Then you can assign any relationship attributes to this relation. So according to that, you can see, you can map this one like this. Okay. Then I'm going to give you a small example. Can you take 5 minutes and can you complete this within 5 minutes? Can you map this into a ER, that means relation schema? No one in the class. Can you do this?
We'll try, ma'am.
Okay, you can try. This is a ER diagram. So you can map this ER diagram into a relation schema. I will give you 5 minutes to map. First, you need to map entities available in the ER diagram. You can identify the strong entity and the weak entity available in ER diagram. Please identify the entities. So what are the entities available in this ER diagram?
A, B, C.
A, B, C. So you can create 3 relations for A, B, C. Okay, all these 3 entities are strong entities. Okay, let's take A, B, C. Okay. Do it by yourself. After that, let's discuss. Okay. Is it difficult? Did you finish it? No students in the class now. Did you finish it? Or do you need more times to finish it?
Not yet, ma'am.
Okay, do it. I think now time is enough. Let's discuss this with together. So are there anyone who finished this one? Is it difficult? I want your comments. Is it difficult? No one in the class, no?
Yes, madam. I can't understand.
Okay, let's see. So this is a ER diagram. So we need to convert this ER diagram into a relation schema. First, you need to consider about the entities. So someone said that the A, B, C are the entities in this relationship. Yeah, you can see A is the entity, B is the entity, and the C is the entity. Are there any weak entity in this relationship?
BZ.
Which one? Weak entity.
B is an optional one.
Yeah, B is the optional one. I'm talking about weak entity. Weak
No,
entity
ma'am.
is represented by double line, like double rectangle. Okay, there are no any weak entities. So let's take, wait. Let's take three entities as three relations. So A, B, C are the relationships. That means relations. So let's take A. When we consider about A, you can see this is a primary key. This is a simple attributes. You can directly write it like this: AA, then AX. This is also an attribute. This is a simple attributes, no composite. This is no composite attributes in this ER diagram. So this is AX. Then let's move into, before moving to B, let's move into C. So when we consider about C, there are two attributes as a CY and the CC. So what is the primary key?
CC.
Yeah, CC is the primary key and CY is another attribute. Okay, already map this. Okay, then let's consider about BP. So BP is an entity. So when consider about BP, you can see there are two attributes. This one attribute is BB. The another attribute is BZ. But when we consider about this BZ, it is a multi-value attribute. So when you are mapping a multi-value attributes, you need to follow some step. What is that? What is that step?
Have to create an additional one for that one.
You need to create an additional relation. So let's take this additional relation as B underscore BZ. So when we consider, so this is, sorry, this is C, this is B. So when we consider about B, this B has only one attribute as a BB. So this is a primary key attribute. When you are mapping a multi-value attribute, you can insert the primary key of the entity BZ, sorry, BB, and the multi-value attribute as a BZ. Okay, so this is about this is about main entities. Okay, then let's move into relationships. We already discussed about, we already mapped the entities into relations. No weak entity, only strong entities are available in ER diagram, and you go map all the attributes. That means all the attributes available in the entities by considering whether they are a simple attribute or a composite attribute or a multi-value attribute. We already mapped those things. Then let's move into relationship. Then first of all, let's consider this relation, one-to-many relation. So these are the two entities. Saranjana, I think. Do you have any question? Saranjana raised hand. That's why I'm asking like this. Do you have any doubt? I think it was a mistake. Then let's take A-C relationship. So again, raised hand. Do you have any question? Okay, I think no questions. Okay, if you have any question, you can drop a message to a chat box. Then you can see, now we are going to consider about relationship time. You can see a, wait, who is this? Then Saranjana. Oh yeah. Do you have any questions? Okay, let's consider this relation, one-to-many relationship. So how we can map this one-to-m relationship into a relation schema?
By using a foreign key.
Yeah, by using a foreign key. You can include one side primary key into m side as a foreign key. That means one side primary key in many side as a foreign key. Then the A is the one side, A is the entity in one side and C is the entity in many sides. So you can include A as a foreign key of this entity. Okay. Then this is,
Excuse me.
go ahead.
When you mention the foreign key, do we have to underline it under it?
No need to underline it, but if you underline it, use dot, that means dash line, no? This one, not the underline. This you can underline by using a dash line like this. Okay.
Okay, ma'am.
It's for foreign key. This is for prime. So this is for primary key. This is for foreign key. I think this is dash line. No? Yeah, this is dash line. You can use dash line to indicate the foreign key. Then this is finished. Then let's consider about one-to-one relationship. So what is the optional entity?
B.
B is the optional entity. So what are the steps followed when this entity is the optional entity?
It should have the primary key of the A entity and the attribute of the relation.
Yeah, you can say this is a BB. You can, sorry, this is a B side. No, yes, might be this one. You can include ABX and AA to this relation. Is it clear? This is an optional one. You need to include the primary key of this side into this side, and you can include the attributes in the relation to this relation schema. So you can see BB is a primary key of this one. Then you can include AA as a foreign key. Then you can include ABX as a attribute. Okay. Then it is also finished. Then the last one. This is in many-to-many relationships. So what are the things you are going to consider when you are mapping many-to-many relation?
We have to make it as one-to-many.
Yeah, you can make it as one-to-many.
So BC will function as
Include an entity.
attribute.
Sorry?
Identity.
Okay, let's consider this as a one-to-many. Let's take a composite attribute as a X. I think it is X. Okay. Then this is belongs to BCX. Okay. Now you can see this is the composite attribute. This side is one-to-many. This side is one-to-many. So you can see this composite attribute is X, and there is attributes available in the attributes available in this composite entity. It is ABX. You can directly write this one ABX. Then you can indicate the primary key of this side into this relation BB. Then the primary key of this side into CC, because this is the many size. You need to include the primary key of the one side into a foreign, into a in many side as a foreign key. So you can see these are the attributes available in this relationship. Is it clear? Are there any doubt? Or are there any missing things? Hansika Kaushalya. Okay. Is it clear? Can someone answer my question? Is it clear?
So yes for us, but I'm not sure about the others.
Excuse me, madam. Can you re-explain the double circle thing BZ, the B entity?
This one.
Yes.
So this is a multi-value attribute. That means this is just like a telephone number. When you are consider about telephone number, you can have more than one telephone number. So this is a multi-value attribute. When there is a multi-value attributes in your entity or in your ER diagram, you need to map a new relationship with this multi-value attributes. So when you are consider about this B entity, this is a B entity. There are two attributes, BB and BZ, but this is a multi-value attribute. So you have an ability to map only a single or a simple attributes in this relation. So you can take BB as a attributes in this relationship. But when we consider about BZ, this is a multi-value attribute. So you need to create a new relation. I took this relation as a B underscore BZ. This is consists with this BZ attributes, and also you need to include the primary key of this entity as a attribute, primary key of this entity as a attribute in this relation. So if you have a multi-value attributes, you need to create two relationships. One is with one relationship, there are two relations. So one is with multi-value attributes, other one is with simple value attributes. Okay.
Then under the B entity, we have BB and BZ both. And again, we create a new entity that is B underscore BZ. They are also we are including both the primary.
This is not a BZ. This is ABX. Sorry. This is ABX.
Okay, ma'am.
Due to this one-to-one relationship and the optional, this is due to relations. Okay. According to the end, so only one attributes as a BB, and there is another relationship with this BB and BZ. If there is another attributes like CC, you can definitely insert this CC into this B relation. You can create two relationships with the simple attributes, one relationship with the simple attributes, other relationship with the multi-value attributes with the primary key of the entity.
Okay, ma'am. Thank you.
Okay.
Yes.
Okay, I think it was clear now. If you have any doubt, you can drop a message to a chat box. Then let's discuss about our next topic. It is about data normalization. That means database normalization. No need to. This is the answer for 20. I think no name. Yeah. So you need. Madam, when we are mapping the schema, here we need to show the three different schema diagrams as there are three different relations. No, we can indicate all these three in one diagram. This is the finalized one. You can draw three schemas separate, and this is the finalized one. This is the final schema for this ER diagram. So these schemas are very essential when you are doing advanced database management system. That's why I discuss about these things. You need to have some idea and some, you need some basic idea about this relation schema when you are doing ADAPMS and also database normalization. That's why I did this one. This is not available in your book. I think, I will upload this into a Moodle. Okay. Then let's move into data tables and the normalization. Database tables and the normalization. So first of all, let's discuss about what is this database normalization. What is this normalization? So the normalization is a database technique which is used to, that means it is a technique, that means designing technique that reduce the data redundancy in your databases. So you know, when you are creating a database, you can have some data redundancies. So the normalization is a database designing technique which is used to reduce the data redundancy in your database, and also it eliminates some undesirable characteristics such as insertion anomalies, then the update anomalies and the deletion anomalies and so on. So let's discuss about what is this normalization. Simply, this is a database design technique which is used to reduce the data redundancy in your database. So when we consider about the normalization, this normalization works through a series of stages called normal form. Normalization works through a series of stage called normal form. So when we consider about the normal form or a normalization, we can divide this normalization into 3 stages. The first stage is known as a first normal form. Then the second stage is known as the second normal form. And the third stage is known as a third normal form. But when we consider about this, apart from this, in this lesson, we are going to discuss about BCN. This is also a normalization stage. So there are 2 normal form, 3 normal form, 1 normal form, first normal form, second normal form, and the third normal form. Okay, so when we consider about the structural point of view, this 2NF is better than the 1NF. 2NF is better than the 1NF, and the 3NF is better than the 2NF. So when you are doing the normalization for your database, most the business database designing purpose, they take this third normal form as their high normal form. That means they took the third normal form as a desirable level or the most desirable level. Okay. But there are some cases or there are some operation when third normal form is not the most desirable one. At that time, you need to decompose this, or you need to convert this that means highest normal form into a lowest normal form. This scenario is known as a denormalization. So the denormalization produces a lower normal form, that is the third normal form will be converted to the second normal form through the denormalization process. Okay, so simply the normalization is the database technique which is used to reduce your data redundancy in your database. Okay. Okay. Then let's consider about need of a normalization. As an example, let's take a small business application. So let's take a small company. This company is a building company. This is a building company. They have some construction projects and they conduct some building, that means construction projects. So when we consider about company has a company maintain projects. So project, when considering about project, this project is consist with project number, then the name and the employees assigned to it. So the employee also has employee number, name, and the job classification such as engineer or a computer technicians. So again, let's take a small business company. This is a building company. This building company maintain some building projects or a construction project. So when we consider about projects, these projects have their own number, name, and the employees are assigned for this project. So when we consider about the employees consist with employee number, name, and the job classification. Job classification means designation. Okay. Okay, then when we consider about this company charges its client by billing the hours spent on a contract. So the billing hours, so the charges is based on the hours. Okay, so the company charges from its clients by billing the hours spent on each contract. Then the hourly billing rate is depend on the employee's position. So the charges are based on the hours that they spent for the project or a contract. Then this hourly rate, that means, yeah, this billing rate, billing hours, this company charges according to the billing hours. So after that you can calculate billing rate. So this billing rate is dependent on the employee's position. So when we consider about employee 1 and the employee 2, the billing rate of E1 is equal to 24.24. This is 2.41. This billing rate is depend on the designation or a job description. So this can be an engineer, this can be a technician. Okay, this is a small business company. This is a building company. So in this company, you can see there are two entities, projects and the employees. The project is consist with project names, project ID. And when we consider about employees, these employees consist with employee number, name, and the job classification. The company charges from the client based on the billing hours. So billing rate is based on the employee's position. Okay. You can see this is the sale report layout of this company. You can see this sales report layout, project number. This is the project number 15. This is the project name. These are the employees works for this project. And these are the names of these employers. Then these are the job category or a designation. And this is the hourly charge. So this one, let's take Nimal K. Pereira. He charged 105 rupees per hour. Then the Kamal Pir is a programmer. He charged 35.75. That means 35 rupees for 35 rupees and 75 cents for 1 hour. So this is the hour charge. And when we consider about hours bill, this person, let's say this one, is Kamal work 35.7 hours for this. So this is the total charge. So this is the sample report layout in this company. You can see, get another example. Let's take this one, Callum Empiris. He is a DSS analyst in this company. Employee number is equal to 112. So he works for project 8 and also he works for project 25. So when we consider about this person, that means Callum Empiris, the hourly charge of this Callum our charge of column is equal to 45. That means 45. It's nearly 46. And he spent 44 hours. 44. Yeah, let's take 44 hours for this project. That means project number 18, loan track project. And he spent 1.4 hours for 25. That means project number 25. That is no name for the no? For project 25, and this is the total charge for these are total charge for column MP. So this is the sample report layout of this company. So when we consider about this sample project, to discuss about data normalization, you need to convert this into a table. Okay, let's see how you can convert this into a table. So this is the table. I think this is available in your reference book. Project number, project name, employee number, employee name, job class, hour, change hours, and that means charge hours and the hours. These are the attributes available in this table. You can see this column is eliminated and this is also eliminated. So you can convert this into a table like this. Okay. The total charge is the product. The total charge is the product of hours billed, and the charge per hours, it is only the item missing in this figure. Then unfortunately, the structure of this, that means structure of this figure 20.2 does not confirm the requirement we discussed in the early lesson in the relational database model. You can see there are so many duplication values. So when we consider about Kamal Perez, you can see the same set of data repeat in many records. Okay, so this is not in a good database module. Okay, then when we consider about this table, can you identify the primary key of this table? So what is the primary key of this table?
Employee number.
Employee number. There are some duplicate values now. 106. There are 2.
Employee name.
Sorry?
Employee
Project
name.
number.
I can't hear you clearly. Can you say it again?
Project number.
Project number. There are so many.
You can't give single field,
You can.
none of the single field we can't give it.
Yeah, you can take composite key. So what is the composite key? Go through the table and
Project number and employee number.
Project number, employee number, and name.
No need to take the name, but you can just take these 2. Because when we consider about this one, only one record for one employee. When we consider about project 15, project 18, one record for one employee. This one also one record for one employee. So you can take project number and the employee number as the composite key. No issue when you are taking these 3 also, but this 2 is enough. Project number and the employee number. Okay. Okay. So the project number is apparently intended to be a primary key or at least a part of the primary key, but it can stay null. The table displays the data redundancy. So the table entry is invited for the data inconsistency. So you can see, as an example, you can see some anomalies occurred in this table. There are some null values. You need to fill these null values. And you can see there are many duplication values. So there are so many data redundancy. Let's discuss about the data redundancy available in this table. So first discuss about update anomaly. So if you need to update 106, the Kamal period is hourly charge as a 40. Yeah, hourly charge as a 40. You need to update 2 records. If you miss 1 record, it may occur the update anomaly. You can see there are 2 records. So if you are update this 35 into 40, you only change this record. So at that time, you can see it may lay the foundation for update anomaly. Then the next one is insertion anomaly. As an example, let's take another employee. This one 200 is joined to this company, but still he is not assigned for any job. So you cannot insert this data into your table, because if you need to insert this one, you need the project number and the project name. So at that time, you can see some insertion anomaly. That means you cannot insert this employee into this table without having a project for him. Then the next one is about deletion anomaly. If you are going to delete 100 and let's take 105, yeah, you need to delete. As example, let's take this 105 is going to quit the company. So at that time, you need to delete many records. So if you are only delete this record, it is a mistake, or it is a in deletion anomaly. You need to delete this is also. So you can see this table lets greater foundation for data redundancy. So the main objective of this data normalization is to minimize this data redundancy. So let's see how we can minimize this data redundancy in this table. So this is the need of normalization. You can see there are so many data redundancy, and if you are taking this database as a good database, it is needed to have minimum number of data redundancies. So we need to convert this table or a database into a good database by applying data, that means applying database normalization. So that is the need of database normalization for this table. Okay. This is a description about this update, delete, and insertion anomaly. Then suppose this Callum Empirics is assigned to work on the treasure trove project. The data entry clerk must update the project file with the entry like this. So you can see the Callum Empirics available in 3 or 4 records. I think 3 records. Callum Empirics. Which one? Callum Empirics 112. You can see there are one record now. Yeah, at
2
that.
men.
Oh, in which project? This one.
Project 25 and 18.
82. Okay, you can see there are 2 records. So the data entry person need to modify 2 records. So imagine this person is work for many projects. So you need to update or insert same data in many records. So you need to type the same data set again and again. So that lays a foundation for data redundancy. So you need to minimize this one. To minimize this data redundancy, you can normalize your database. So when consider about normalization, the first stage is first normal form. Let's discuss about how we can perform this first normal form. According to your book, there are so many descriptions, but I think that is not clear. So the first normal form. So when you are consider about first normal form, if a relation or a table will be in a first normal form, if there is no repeating rows at the intersection of each rows and columns. That means the value at the intersection of each row and the column must be a atomic value. So you can see when consider about this one, and you can see there are so many non-values when mapping this into a table, this sales report into a table. You can see there are so many null values. So you need in the first normal form, the requirement is the relation will be in one normal form if there is a no repeating rows at the intersection of each rows and the column. So at that means you cannot have the values like this. There are two values now, so you need to have an atomic value for each row and column intersection cell. Okay, so this is the requirement in the first normal form. You can see this one. There are so many null values, that means these are null values. So you need to convert these relations into a first normal form. So the relation table must not contain the repeating group. And if the repeating group do exist, they must be eliminated by making sure that each row defines a single entity. The process is simple, just add the appropriate entity, at least the primary key column. So you can see this, you can convert these tables like this. So now you can see this, each entities are single. You can take this as a single entity. So this is as a single entity. At that time, this value is common for all these. So it makes some data redundancy. So you need to take all these as a single entity. So you can convert your table like this. So this table is converted. This table is converted like this in first normal form. Now we can say that when consider about all the rows and the entity intersection cell, it contain single values. So we can say this is in first normal form. This example is not good example. After discussing these slides, let's discuss another example. Okay, you can see this is in a first normal form. Okay. So in this case, you can see project number is not a primary key because you cannot use this field to identify each and every records uniquely. So to maintain the primary key that will be uniquely identify any attribute values, the key must be composed of combination of project number and the employee number. So according to this one, you can take this and this as a primary key of this table. You can see and consider about 15 and 103. No, there are no other values like 15 and 103. So you can take these two attributes as a composite primary key of this. That means composite key of this table. Then now this is in first normal form. So keep in mind, if a relationship is to be in first normal form, the value intersection of each rows and column is a atomic value. So all these are atomic values. So this is in a first normal form. Though no null values, so this is in a first normal form. Then let's discuss about dependencies before moving to second normal form. So you can see this is the primary key, this is the primary key. So these two are get together to form a primary key of this relation. So this is a relational schema of this table. So the arrow of the entity indicate all the desirable dependencies. So when we consider about the table, you can see there are dependencies. We already discussed about these dependencies. A determine B. I think in our previous lectures, we discussed about A determine B and B determines C. Likewise, we discussed about the dependencies. So you can see there are so many dependencies available in this relation. Okay, so when considering about this table, you can see there are two dependencies as a partial dependencies in the and the transitive dependencies. In this second normal form and the third normal form, they are going to eliminate this partial dependencies in the transitive dependencies. Before discuss about second normal form, let's discuss about what is this partial dependencies. So you can see a relationship is in a partial dependencies. So that means, as an example, let's take like this. If the attributes is depend on a part of composite key, this is known as a partial dependency. As an example, let's take this table A, B, and the C. So A and B are the primary keys which contribute to form the A and B are the attributes which contribute to form the composite key. So you can see A and B. This C is depend on B. So this C determines B determines the C. So the C is depend on B, but this is a part of a primary key. So this type of dependencies on sorry. So this type of dependencies are known as partial dependencies. Is it clear? You need to have an ability to identify the partial dependencies as well as transitive dependencies. So is it clear?
Yes, madam.
What about others?
Can you re-explain again, Manu?
Okay, I can explain it again.
The partial dependency.
Yeah. So as an example, let's take this is the relation schema A, B, C. These are the three attributes available in a relation. So the primary key is, this is in this relation, there is a composite key as a and B. So you can determine, before that, you can determine A, B. We discuss about this determination. That means this B is depend on A. That means B attributes is depend on A. So you can see when consider as an example, let's take A, B, C. A and B are the primary key of this table. So this C is only depend on B. Then the C is only depend on B. That means we can denote it like this. So you can see this C is depend on the part of the primary key. So these two get together to form the primary key, So, but this C is only depend on B. So you can see this C is only depend on B. This is the part of the primary key. At that time, this dependency is known as a partial key. That means part of the composite key. If the attribute is depend on the part of the composite key, that attribute is known as that dependency is known as a partial dependency. Is it clear? Is it clear, or do you?
Yes, madam,
Okay.
clear.
Okay. Then let's discuss about the transitive dependencies. When consider about some cases, there are some cases like this. This job class, as example, let's take this job class. This our charge is based on job class. It's already mentioned in the scenario. The hourly rate is wait. You can see this one. Wait. Give me 1 second. What is that? Yeah, this one. The hourly rate is depend on the employee's position. So you can see when consider about this relation, which this relation job class means job description. So you can see this hourly change rate is depend on this job class. So this is, that means as example, let's take this one as a B, this one as a. So this B is depend on A. You can see this is not a prime key. Prime key means, okay, before that you need to have some idea about prime key. No? So you can see any attribute that is at least a part of a key. That means a super key, primary key, candidate key, composite key, or a foreign key. Any attribute that is at least a part of key, this type of keys are known as, this type of attributes are known as prime attribute or a key attribute. Okay, so when we consider about non-prime attribute or a non-key attribute, it is not even a part of a key. So you can see there are two types of keys. We can divide these keys into two categories as a prime key and non-prime key. And consider about prime key is a part of a key attribute. That means yeah, when we consider about non-prime key, it's not a part of a key entity. Okay, so you can see this is not a prime attribute, this is a non-prime attribute. So these two are the key. No, so this is not a key or a key or a part of a key. So this is a non-prime attribute. You can see this B attribute B is depend on non-prime attribute. This is also a non-prime attribute. This is also a non-prime attribute. At that time, this dependency is known as a transitive dependency. Is it clear?
Yes, madam.
Small thing, transitive dependency means non-prime attribute depend on a non-prime attribute. Non-prime means, according to the definition, not even a part of a key. That means just normal attribute. Okay. So these are the two types of dependencies available in table. Okay. Now we are going to identify the dependencies. Okay. Before this, I'm going to draw this in. Can you identify? Okay, I will wait. Let's take this one, project number. Okay, then the project name. Then employee number. Okay, then employee name. Then job class and hourly rate. It is not clear, no? Wait. Project number. Yeah, I'm going to upload this into Moodle. Sorry, project name. This is name. Then employee number. Then job class.
Madam,
Excuse me.
if you're writing something, we can't see it.
We can
You're
see only the
writing something.
slide.
Okay, I'm
PDF.
going to share it. Wait. I think I didn't share it. Give me 1 second. Wait, give me 1 second. There are some issues in. Sorry. Okay, can you all see now this my whiteboard?
Yes, ma'am. Now okay.
Job class, then our rate, then number of hours. Project name. So employee number and the employee name also. Yeah, employee name. Okay. So there are 6 attributes: project number, project name, employee number, employee name, job class, then the hourly charge and the number of hours. Okay, so can you identify the dependencies available in this table? So project number and the employee numbers is the primary key of this table. So can you identify? Okay. So in this table, you can see there are 2 records of 2 entities available in this table. In this table, it is consist with the data of projects as well as the employees. Okay, so you can see project number. So what are the dependencies, dependent attributes available on this table depend on project number. So what are the attributes?
Project name.
Yeah, definitely project name only depend on project number. Okay, so when consider about project name, it is depend on project number. Is I'm going to tell like this: employee name is depend on project number. Is it clear? Is it true? Employee number is not employee number. Let's take, yeah, employee number.
No, ma'am.
Okay, then let's discuss about our next one, employee number. This is another primary key. Now, what are the attributes depend on employee number?
Employee name, job class,
Employee name, then the job class,
and the charge per hour.
and yeah, charge per hours. Okay. Then when we consider about these 2, that means this is a composite key. Now all these attributes are depend on these 2 composite, that means 2 attributes. Let's take these 2 together. Project number.
That charge per hour is not depend on the employee number, no? That charge per hour is so only on the employee category, no?
No, charge hours is depend on the destination of
Designation of, so it is depend on, as example, this number of that is charge hour is depend on designation. So designation is depend on job class. This one is depend on employee number. All these 2 attributes are depend on employee number. So the same employee ID, the employee name and his designation, then the hourly rate. Okay. Then project number and the employee number. It is very difficult to write in this whiteboard. Okay, so what are the attributes depend on these 2? That means the candidate key. When consider about a primary key or a composite key, all the attributes available in the relationship is totally depend, that means is depend on these 2 keys. So you can see project name and the project number, all other attributes are depend on this one. Apart from this, you can see this charge hour is directly depend on job class. Okay, there are 4 dependencies available in this relationship. Wait, you can see and consider about this relation. This project number is partially depend on project name is partially depend on project number. When we consider about project number and the employee number. All other fields are depend on this project number and the employee number. But when we consider about employee number, employee name, job class, hourly, change hours, that means charge hours are depend on this employee number. And the final one is this one. This is very important. This is not a partial dependencies. This is a transitive dependencies. This charging hour is based depend on job class. So you can see there are 4 dependencies available in this relation. You can identify this relationship when you are reading this scenario. Go through this and get some idea about this when you are referring your video. Okay, so you can see employee number, employee project number. These are the attributes depend on this one. This is a partial one. This is also partial dependency. This is also partial dependency, but this is a transitive dependencies. So you can, this is the table structure can be shown in, table structures can be shown in the following format. You can see this is the relation name, then the primary key and other dependent attributes. Okay, you can see when we consider about charge, project number, employee number, these are the attributes available in this chart or in this table. Okay, when you are representing these relations in a table format. So we discuss about key attributes. If attributes is a part, at least a part of a key, that kind of attributes are known as a key attributes or a prime attribute. So the attributes not even a part of a keys are known as a non-prime attributes. So you can see the relation table satisfy the 1NF requirement. So in 1NF requirements, you can see this table is in one requirement. 1NF, that means first normal form, and also we identify all the partial and the transitive dependencies available in the relation. Then let's move into second normal form. Before that, you can see partial dependencies cannot be tolerated because the table that contains such dependencies are still subject to the data redundancy. Yes, definitely partial dependencies also laid foundation for data redundancy. So in the second normal form, we are going to eliminate these partial dependencies. In first normal form, we make all the set attributes as an atomic attribute. In the second normal form, we are going to eliminate all the functional partial dependencies available in the relation schema. So you can see this is an example for the partial dependencies available in this case. Wait. So when you consider about the first one, you can see the same data can be repeated again and again when consider about first partial dependency. So when we consider about first partial when consider about all these partial dependencies, same set of data repeat again and again. So in this case, employee number, job class, and the charge hours. So in this case, it is also have an employee number. So the same set of data repeat again and again. So we can take these dependencies as a separate tables or a relation. So you can see this is employee number appear in this relation as well as this relation. So the same set of data available in two relations. That means same set of data again and again repeated. So we need to eliminate these partial dependencies. To eliminate these partial dependencies, we need to move into the second normal form. You can see the second normal form. This is the conversion to the second normal form. The relational database design can be improved easily by converting the database into format as known as a second normal form. To convert a table or a relation, convert a table or a relation into a second normal form, definitely it should be in a first normal form. That means every cell intersection point need to have an atomic value. Okay, so if you are going to convert the first normal form into a, that means data set into data table into a second normal form, definitely it should be in first normal form. Then you can consider about the partial dependencies. So the relation will be in second normal form if it is in first normal form and every non-key attributes is fully function depend on a primary key. So at that time you can see there are some partial dependencies. Partial dependencies means they depend on both so part of the primary key. So in this case it is needed to be in fully dependent on the primary key. So that means no partial dependence is available in this second normal form. So you need to eliminate this partial dependency to achieve the second normal form. Okay, so you can see these are the key attributes, or these are the dependencies in project number, employee number, project number, and the employee number. You can see these are the keys. You can define three relations according to these tables. According to these dependencies, there are three. There are already there are four dependencies, but one is transitive dependencies. You can see there are four, but this is transitive dependencies. We do not consider about these transitive dependencies when you are in second normal form. It's only discuss about partial dependencies in second normal form. So you can see these are the three partial dependencies. Okay. Then you can see according to these three partial dependencies, you can create three tables as or three relation as project, employee, and this can be taken as a assign. This is project. This contain information before that. Wait. Okay, I think now it was clear. You can see. These are the partial dependencies. This is not a partial dependencies. So you can say this is about project, this is about employee, but this is about employees and the project both. Okay. So you need to create three relations for each dependency. So you need to create three relations like this. Okay. Then you can see that we can take this first one, this one as a project. You can take this one as a project and this one as an employee, this one as a assign. You can take this relation as a project relation. You can take this relation as an employee. Can you all see this stepping tool image?
Yes, ma'am.
Okay. You can take this one as an employee, this one as a project, this relation as a assign. Okay, now you can see the project relationship. This is the project name. This is employee relation, employee number and employee number, then assign project number, employee numbers and the others. So you can see this, there are some other attributes, okay? You can see there are three tables. This is the project table. Project number is the primary key, then the project name, and employee number, employee name, job class, and the hours. Then you can take two. Okay, before that, I think you have some doubts. So when we consider about this one, you can see this is about project name. Okay, this is about employee. So when we consider about this relationship, you can see the same set of data duplication. You can see that this one. This employee number again, project name again, okay, and job class again, job hours again. So to eliminate these partial dependencies, we are going to create three relation. one relation to the project, one relation to the employee, and another relation for this assign, but without having this duplicated field. Okay, so you can see the project, when consider about project relation, it's only consists with project number and the project name. When we consider about employee, employee number, employee name, job class, and the charge hour, this is transitive dependencies. Then we are going to eliminate the dependencies. So when consider about this one, this is this one, all the attributes are dependent on another relation, so we are going to eliminate this one. So we can eliminate these attributes, that means in this case you can eliminate these attributes and you can just indicate this as a assign relation. You can see project number and the employee number is the same set of is a composite key of this table. Then you can eliminate other attributes and you can include others. So you can see there are three relations after eliminating the partial dependency. So you can see when consider about project number 12, project names only in these tables, employee names only in this table. So these are the reference to these tables. So you can see now this table is in second normal form. To convert this one, so first you need to, let's go through the lecture note. The first one, the first normal form to second normal conversion is simple. Start with one normal form, formatted, display the figure in 20.5, that means this figure, and the key component on the separate line, then write the original key on the last line. Okay, then each component will become a key in a new table. In other words, the original table now divided into three tables: project, employee, assigned respectively. Write the dependent attributes for each new key, and the dependencies for the original key components are found in examining the arrows below the dependency diagram. So you can see these are the dependencies. Then you can create the relation like this. So this is according to your book, but when you are converting your relationships or a first normal form relation into a second normal form, you need to consider about partial dependencies, and you need to eliminate all these partial dependencies, and you need to create the full functional dependencies. Okay, then when we consider about this one, then about third normal form. Before moving into third normal form, let's take a small break. Is it okay?
Yes, ma'am.
Okay, let's take a small break. You can do this one. This example. Let's take a small break, 15-minute break. Within this break, you can go through this table and you can convert this into first normal form. Shall we start now?
Yes, madam.
Okay. Okay. So we discussed about second normal form. You can see after eliminate the partial dependencies, you can see this kind of relation schema or a table schema. You can see in this case, this project name is totally depend on project number. So this is not a partial dependency. because when we consider about this relation schema, the project number is totally dependent on project name is totally dependent on project number. So this is a fully dependency. So you can see this is not a partial dependency, but when we consider about this one, employee number, all these three parts are depend on a primary key or a candidate key, primary key. So this is also fully dependency. And when we consider about hours, it is based on both employee number, depend on both employee numbers and the project numbers. So that means this is based on whole composite grid. So there are no partial dependencies. So because the partial dependencies can exist, only the table's primary key is composed of the several attributes. The table whose the primary key consists of a single attributes must automatically be in a second normal form. It is in one normal form. As an example, in this case, we take we take composite key as a, that means in this table you can see in this table is consist with composite key, but when we consider about the when we consider about a table which is in one normal form with the primary key, you can see it's definitely in two normal form. You do not need to convert this into a second normal form because only one key attribute or a key is available in this table. So is it clear? First normal form and the second normal form. අපි first normal form එකේදී කරන්නේ අපි intersect point when intersection වෙන point වල අනිවාර්යෙන් atomic value එකක් තියෙන විදිහට table එක construct කරගන්නවා. ඊට පස්සේ අපි partial dependencies මොනවද කියලා හොයන second normal form එකේදී ඒවා හොයලා ඒ partial dependencies eliminate කරනවා. Partial dependencies වලදී වෙන්නේ මොකක් හරි non prime attribute එකක් candidate දැන් composite key එක part එකක් මත විතරක් depend වෙනවා. අන්න ඒ වෙලාවට අපි කරන්නේ ඒක අයින් කරලා totally depend කරන විදිහට හදනවා. ඊට පස්සේ පුළුවන් අපිට convert කරන්න eliminate කරන්න partial dependencies. Partial dependencies eliminate කරාට පස්සේ අපිට එන relationship එකේ or relation schema එක හැම relation එකක්ම depend වෙන්න ඕනි whole composite key එක මත හෝ primary key එකක් තියෙනවා නම් ඒ primary key එක මත අන්න ඒ විදිහට වෙන විදිහට අපි relation or table හදා ගන්නවා. Okay, then let's move into third normal form. Yeah. I will explain this after explain about 3NF. Okay, then let's discuss about 3NF. In 3NF, that means third normal form, the main objective of this third normal form or a main requirement of this third normal form is to the relationship is in a second normal form and no transitive dependencies exist. So according to our previous case, you can see there is a transitive dependency. This one job class and our charged amount. So you need to eliminate this transitive dependency in third normal form. So in second normal form, they consider about the partial dependencies. In the third normal form, they consider about the transitive dependencies. So you can see job class. Job class must be retained in the original 2NF table as a foreign key in order to establish the link between the original table and the newly created table. So you can see the project number. Then you can, let's take this one. You can see we already mapped these 3 into relations or a tables. Then let's discuss about this transitive one. So you can see the charge hour is depend on job class. Now we are going to create another relation for this transitive dependency. We can take this as a job. This is the job relation. So in this job relation, you can see job class and the charge hours. Okay. So you can take this job class as the primary key of this relation. Okay, now there are all together 4 relations. The first 3 from partial dependencies. At that time, we can say this relationship is in second normal form. After that, we are going to convert the second normal form relations into a third normal form. At that time, you can see one transitive dependencies. So you can convert these transitive dependencies as a fully dependent relation. So note that this conversion has eliminated the original employee table's transitive dependencies. The table are now said to be in a third normal form. Having cleaned up the table structure and eliminate troublesome initial, partial, and the transitive dependence. Now we are already eliminate all the partial and the transitive dependencies in this table. So we can now turn our attention to improving the database's quality to provide the information to enhancing its operational characteristics. So you can see now the table is in normalized third normal form. I think according to their requirement, it is the desirable level. So now you can apply other operation to make your database in good. That means improving the database ability to provide the information and enhancing its the operation characteristics. So you can see the first one is, this is the first case, as the number of employees grows a job class value must be entered each time in a new employee is entered into a table. Unfortunately, it is too easy to make data entry errors to lead the referential integrity violation. So as an example, you can see when consider about this job class, so some can be DB, some can be enter that as a DB designer or a database. This is a type of employer, DB designer rather than DB designer. So this is database. This is shortened form of database. So it triggers such a violation. Employee table can be occurred in violation. As an example, let's take if you are going to enter job class as a DB designer. In this case, the person who entered the data, that means the typist, entered this job class as a database designer. There are 2 attributes. So in this case, it type as a DB designer. In this case, database designer. So at that time, you can see some doubts available in this table. So we need to eliminate this kind of doubts and this kind of issues. So you can take another attribute as a job code to eliminate this kind of issues. So the in addition job code attribute produce the dependency. So you can see දැන් අපි හිතන්න මේ data එක මෙන්න මේ employee as an example, let's take employee table when we consider about this job class is available in the employee table, and there is another table as a job. It also has the same attribute, job class. So in this case, the person who entered the data is entered as a DB designer. But when you are entering data into this table, you are going to enter this as a database designer. So you can see at that time it will definitely trigger a error message because there are no records as a DB design. The make data enter කරන්න අනිවාර්යෙන් මේකේ data එක තියෙන්න ඕනේ. මොකද මේක this is belongs to this table also. So this is just like a foreign key. So at that time you can see there are some integrity violations. So to avoid this integrity violation, you can introduce a new attributes as a job code. So you can define a job code according to the job class. After that, you can use job code to insert data. So this new attribute does produce a transitive dependency if you assume that the job code is a proper prime number. Okay. Presence of job code greatly decreased the likelihoods of referential integrity violation. So you can see it is the best to adhere the name in conversion. Therefore, we can change our to job, change our to indicate the associated with job table. So in addition, the attribute name job class does not quite describe such entries as a system analyst, database design, and so on. The label job description fits the entries better. So job class attributes, you can rename it as a job description because it is very difficult to understand at that time what is meant by this job class. So you can eliminate this kind of things by changing the name job class into those job descriptions. Similarly, use the assign hours rather than hours. Let us associate it at the hours work with the assigned table. So you can see you can change the names of the tables in meaningful way to for purpose of understanding. Okay. Then in generally good practice to pay the attention to atomicity requirement, that is to use the attribute that cannot be further subdivided. So it is definitely needed. You can use atomic or a simple attributes in your database. As an example, if you can see in this table, this is consist with 3 names. So name column is consist with 3 names. So this is a composite attribute. You can subdivide this into a simple attribute. So this is also good manner in database normalization. So you can rename this employee number, or you can create another 3 attributes to represent this employee number as employee last name, employee first name, and the employee initial. So you can then when consider about employee tables, it will use the real world environment. Quite a few other attributes would have to be added. This is up to you. So you can take the basic requirements and you can map this basic requirement into a database, and you can form good normalized database. After that, you can add some attributes, and you can rename the attributes according to your preference. That's up to you. Okay. So you can take the employee hire date as a new attribute for your database. Then you can take employee number as a foreign key of project. These are according to your preference, you can do. Then finally, you can create a table or a schema like this. So when we consider about project number, that means this one. Wait, I'm going to give. Let's take this scheme. This is the final one. This is now, these four relations are in third normal form. So I'm going to take a screenshot. Okay, this is the final normalized relation. So this is in third normal form. You can add other characteristics or other qualities according to your preference. So you can see after adding new attributes, so after modify your database according to your preference and according to preference, so you can create tables like this. The initial, the project is consist with two attributes as a project number and the project name. In this case, you can see it's already add another primary foreign key employee number into this table to make a connection between the tables. So you can insert employee number as a foreign key. Then let's discuss about next table. It is about job class. So in this job class, we already insert a new attributes as a job code, and it can be a primary key of this job code, because when you consider about DB designer, we can write DB designer in many ways. So we cannot identify each and every record by using that kind of attribute. So we are going to introduce another attribute as a job code to this table. So you can see job code is a primary key of this table. So this is about employee project. This is about job. Then let's consider about assigning table. The assigning table, you can see it's consists with the project number, employee number, assigned hours, assigned date, and the assigned number. These two are foreign keys because this is the original table, and when we consider about project employee, this is the original table. So these two are the primary foreign keys. So you are going to introduce a new primary key to identify each and every records in these tables. You can insert assigned number as a primary key. You can insert any, that means you can insert this assigned number as a primary key. So you can see all the records are, you can use this assigned key to identify all the records uniquely. So these two are foreign key of this relation. Then the employee number. So you can take the employee number, all these attributes belongs to the employee entity. Then you can take job code to take the link between these two tables. So this is up to you. You can create the link between every table. So at that time, when considering about this one, if you need to create a relationship between this employee number and the assigned number, you can create it by assign. So inserting a foreign key for a relation. So you can see now employee number, when we consider about the project, when we consider about this detail. So let's take a record as 105 Nimal Pereira. When we consider about the Nimal Pereira, let's see what is the job of this Nimal Pereira. The job code is equal to 502. Let's move into this table. 502. He is a database designer. Hourly range change rate is equal to this one. Then let's let's find what are the projects. Yeah, what are the projects? What are the projects that he is working for? So you can see. Wait. This is 502. This is the Nimal Pereira. When we consider about Nimal Pereira, 502, he is a database designer and hourly range is equal to, sorry, 505. So 105. Then by using this employee number, 105, you can see 105, you can see he's worked for project number 15, but by using this 15 and 105, 15 and 105, where's that one? This one. You can find the assigned hours and the assigned date. Likewise, you can create a link between, you can create the link between each and every tables. So after the conversion, the database in this figure contains the 3 tables in third normal form, project, assign, and the employee, and 1 table in second normal form. This one is in second normal form, okay? Because there is a transitive dependency again, this one. Because we take a job code as a primary key to build it in a good level, but I already discussed about sometimes we need to convert third normal form into second normal form to construct good or a desirable database. At that time, we need to decompose or denormalize our database. So this is just like a case. In first case, we can see this job description is totally depend on this hour range is based on job description, but this is not a primary key. We take a primary key as a job code. So there is a transitive dependency. So this is in third normal form. All others are in, second normal form. All others are in third normal form. Okay. Is it clear? I know it is very complex scenario with this example. So it is very complex to understand with this example. Is it clear? Or you can, what about your comments? When consider about database, you don't need to convert all the tables into third normal form. You can denormalize them into second normal form to create a good database with minimum data redundancy. Is it clear? Can you do this one? I will, now it's already 11:09. Is it clear?
Yes, madam.
Okay. Before moving to the BCNF, it's small. Can you see this example? Can you see this example? Can you all see this example?
Yes, ma'am.
Okay, you can do it. Convert this into, first you can convert this into first normal form. Convert it. Try to convert it first normal form, then the second normal form and the normal form. Try to obtain a normalized database for this step. Yeah, for this scenario, please try to obtain a normalized database. So what is the requirement in first normal form? Can someone answer my question? What is the requirement of first normal form? What is the requirement of a table to be a first normal form? Yes.
So, and one entity occurrence can have only one group. If more than one group repeats, we should have to divide it into separate.
Yeah. You can see only one cell can contain only atomic value. So can you convert this into a first normal form? Very easy. So when considering about this cell, when consider about this row, when this is a row and this is a column, so you can see the intersection of column and a row. So when consider about this row, wait, let's highlight them. Yeah, when consider about this row and this column, you can see this is the intersection point. So when consider about this intersect, wait. This is the intersection point, these two are the intersection point. So you can see there are two values in this cell. So is this table is in first normal form?
Entity occurrence. The null places have to.
Yeah, so you need to convert this into a first normal form. So can you tell me how many records available in this table after converting this into a first normal form?
5.
5 records are available in. Okay. You can see this is the table. I'm going to take this table. Okay. Then, is it correct? Is this table correct? Can you say this table is in a first normal form? Is this table fulfill the requirements to become a first normal form? Yes or no? Simple question. Yeah, primary key must be there. Then you can identify the primary key of this table. So identify the primary key. So
student ID and course.
Yeah, student ID and the course ID is a primary key. Okay, now, so already finished. Then let's move into second normal form. In the second normal form, first you need to identify the partial dependencies and the transitive dependencies. Identify the partial and the transitive dependencies. This is SID, that means student ID, student name, student address. This is the major, this is the course ID, course title. This is the instructor or a lecture. You can take it as a instructor. This is the instructor name. This is the instructor location. That means a lecturer. Let's take a lecturer or anything. Lecturer name and the lecturer location, then grade. So can you identify the dependencies available in this table and how many dependencies available in this table? I will give you 5 minutes. You can identify. Otherwise, no. How many dependencies are available in this? Yeah, how many functional dependencies available in this table? In your exam, you can have a question like this. Try to identify the functional dependencies. Sorry, yeah, functional dependencies. Can some, yeah. No need to, this is address field, not the atom. That means atomic means you talking about, that means this is the Thilan, I think Thilina or anyone. So it is no need to have this as a, at that time you consider this as a composite attribute. No need to consider as this, just consider the atomic value for each cell. That means only one value for this cell, sorry, this cell. No, then when we consider about this location, it is also have a one value. After 3NF, you can divide, like, after you convert these tables into 3NF, you can add your comments and add your properties and add any which attributes according to your preference. No need to do it in first normal form. Just convert this table into third normal form. After that, you can do any performance to any perform, that means any algorithm to make your database in good level.
IDs,
Sorry,
3 partial different
3 partial dependencies. Okay, what about others? So what are the three dependencies?
Sorry, dependencies.
Sorry.
First one, when we take student ID and course ID outside, rest of the attribute will be dependent on that too.
Wait, Vinay. Okay. Okay. Okay, now you can tell. What are the dependencies?
If we take student ID,
Student ID, okay.
student name, student address.
Name, student address. Can you all see my whiteboard?
Yes, ma'am.
Okay, then other one? Only these two attributes?
Another major.
Major, okay. Then second,
Course ID.
course ID.
Course title.
Then
And instructor name.
instructor name, okay.
Instructor location.
Instructor location, okay. Then next one.
Student ID and course ID.
Student ID and the course ID. Okay, so from this,
Student name, student address, those things.
no, by using a student ID and CID, you can, to identify the grade, you need a student ID as well as course ID. So you can take the grade is depend on student ID and the course ID. So by using student ID, you can identify the student names. No, so this grade is based on student ID and the student name. Okay, what about others? This student name, address, major is dependent on student ID. It is correct. So when we consider about course ID, definitely it should have a course title and there should be an instructor allocated for this course. It's also correct. But when we consider about this one, you can find the grade by using the student ID and CID. It is also correct. Then there is a transitive dependency in this table. Can you identify that one?
Instructor name and
Yeah, instructor name and the location. Instructor definitely.
location.
Yeah, instructor location depend on instructor name. This is another scenario. You can see there are 4 dependencies: student name, address, and the major. This is about student details. You can consider about this as a dependency. Then when we consider about course has a title as well as course has a assigned instructor and his or her location. You can take it as this relationship. That when we consider about SID and the CID, grade is based on this one. And when we consider about instructor location, this is definitely depend on instructor name. Okay, so these are the identified dependencies. These are partial, but this is not a prime attribute. So this is a transitive dependency. Okay, now we are going to eliminate the partial dependencies. Can you eliminate these 3? And can you identify what are the tables and the tables in our relations? Identify the tables. I will give you 3 minutes. Identify Okay, so can you, yeah, can you, okay, let's take like this. Okay, so yes, this one. Let's take first relation. This is the SID. So what are the attributes in the SID? This relation. So give a name for this side relation. First,
Student,
student. So what are the attributes?
student name, student address,
And the
major.
major. So how many records available in this student tables? Table. Now we are going to create the tables according to the relation. So how many records available in this table?
2.
2 records, 111 and 212. So you can create a table like this. Okay, this is the table. You can see there are no duplication values available in this table. So you can take this as this is a way, this is in second normal form. Then let's consider about third one, second one, course ID, course title, instructor name and the location. Yes, my dear. Okay. How many records available in this table?
3.
1, 2, and the 3. Yeah. 3 records are available in this table. You can see these are the 3 records. Wait. This is the mistake. You can take like this. So when we consider about CSID, SS11, DBMS, same data. So you can delete this one. Then 22, IS22. There are 4, no? IS11, IS22, IT22, and IT15. There are 4, I think. Yeah, there are 4 different. This is only the duplication, duplicate one. No? So 1, 2, 3, 4. 4 records are available in the course relation. Then the last one, CID and that SID and the CID. That means course title and the student title. So how many records available in this table?
3.
Is it 3? So we are going to take this one. SID, wait. CID,
Fine.
5. This one, this, like this. B, this is C. C. So these subjects are differ from, there are four subjects now. So according to this, these two papers have some graded. So you can see there are 5 available records in this table. So you can see this is a composite key. This and these two fields get together to identify each and every record. So you can see this grade is totally depend on these two attributes. That means this, like this. You can take this CID and grade. Grade is depend on both student ID and the course ID. So this is not a partial dependency. So all these three are not in a partial dependencies, or the partial dependencies are eliminated. So you can take now all the relationships are in second normal form. Then let's convert this into a third normal form. So you can consider this one, transitive dependency, when you are in third normal form. I will give you 5 minutes. You can design the table for that.
On here, ma.
Okay. So then the last one is instructor location. So this is the transitive dependency. So convert this into normal relation and give a name for this. So you can see in this this one instruction name and the instructor location. You can make this instructor name. This is not a prime key now, so you can make this instructor name as a prime key. Then you can create a new relationship with instructor name and the instructor location. This is a primary key. So you can see how many records available in this new relation, instructor relation. Instructor name and locations are going to create another relation. So we can take this as a primary key. So how many records? This record amount is wrong. So how many records available in this table? 3. Yes. Answer is correct. You can see SB is 3 values. So you can take one SB. Then there are 3 records available in this table. So now you can say all the tables are available in 3NF form. After that, you can modify your database according to your preference. You can put foreign numbers to create the link between tables. So you can see, let's take this one. Okay. Let's move this into this. Okay, now you can see now you can see there are 4 tables available in this database. Now you can create a relationship between these 2 tables according to your preference. Okay, if you need to insert the instructor ID, you can use the instructor ID, and you can take this instructor ID as in this table, and you can eliminate this instructor name from this table. So at that time, you can see the link between these two tables. So CSID, this is definitely have a table. So if you need to create a link between these two tables, you can insert the CID as a foreign key of this table. Is it clear?
Actually, after eliminating the transitive
Yeah.
so dependencies, we
Yeah.
can link it, isn't it?
Oh yeah, you can link it. So this is the final normalized database of
So
this.
that's the step.
Yeah. So wait, I will do it also. Give me 1 second. Wait, sorry. Can we take this? Wait. Okay. Okay, you can see these are the tables. So if you need to modify the table, so this is the SID is the primary key. It's difficult to draw. No? SID is a primary key, but you can see when consider about SID, it does not have a relationship between this student table, and this is the student table, this is the instructor table, and this is the grade table, and this is let's take this as a course table. You can see there is no link between this course table and the student table. You can see when consider about 111, the major is IT, but we cannot identify what are the courses that he or she took. So at that time, you can create a link between these two tables by including course ID for this. Explain the 2017 and 2018 NBT question number 2. What is that question? NBT means, so you can create a connection between these two, and you can include instructor ID to this table, and you can eliminate this name, and you can insert instructor ID to this table. Then, yeah, likewise, you can modify your database according to your preference. So, CAT exam. I don't have a question, that exam question with me. කොහෙන්ද මේ CAT exam paper එකේ answer paper එක ඔයාලගාව තියෙනවද? Can you explain the 2000 NBT question number 2? Is it available in the Moodle? Please give me. Yeah, CAT exam paper. So, is it available in the Learn USL? Which one? Content, case, course material, web resources. Okay, it is available. Wait, give me 1 second. I will check. Paper එක විතරද Moodle එකේ තියෙන නැත්නම් answer එකක් තියනවද? Wait. Which one? 2017-18 NBT question number 2. Okay, please give me 1 second. I'm unable to. Question number 2. What is the? So we only discuss about 3NF. No, now we have to discuss about BCNF. After that, I will explain the question. Okay. Okay. Let's discuss about BCNF also. Okay. Then after the third normal form, we are going to discuss about Boyce Codd normal form. This is a kind of normal forms available in the database. So the Boyce Codd normal form is, the table is in Boyce Codd normal form if the every determinants in the table is a candidate key or a term, that means a determinant is any attributes whose value determines other values within a row. So if a table contains only one candidate key, then the 3NF and BCNF are equal. So again, the same scenario. If the table has only one primary key or a one candidate key, only a one primary key, it's also in a BCNF form. Otherwise, it is not in a BCNF form. So let's see how you can convert 3NF into a BCNF. So when we consider about this 3 BCNF, it is a special case of 3NF. You can see table 3NF. Let's see how can a table be a 3NF and not be a BCNF. So this is already consists about candidate key. When you are in the normal form, you can see all the non-prime attributes are depend on the prime attributes. So you can see the BCNF and the CNF is same, but there are some scenarios these two are not in the same. Let's see. To answer this question, you must keep in mind that the transitive dependency exists when one non-prime attribute is dependent on another non-prime attribute. As a other word, you can take this example A, B, C, D. You can see this is the AB get together to these are the two candidates or two so these two attributes get together to form the composite key in this schema. You can see A plus B determines C and D. When we consider about this, C determines B. Okay, so there is a transitive dependency. Wait, can you see like this? This is not a good example. Yeah, wait. So when consider about a table, this table is in 3NF if it is in 2NF, and there are no transitive dependencies in the 3NF. Now we are going to discuss about how can a table be a 3NF and not be in a BCNF. To answer this question, you must first keep in mind that the transitive dependencies exist when non-prime attributes depend on another non-prime attribute. So in other words, the table 3NF is, in other words, a table is in a 3NF if it is in a 2NF, and there are no transitive dependencies. But what about the case which a non-key attribute is a determinant of a key attributes? In that case, we are discussing about non-key attributes and the non-key attributes. After that, we convert this as a key attributes into a non-key attributes. But when you are talking about the non-key attribute is a determinants of a key attribute. The scenario like this, in the previous case, A, B, C, A, B, then C and D. In this case, C and D. These two are non-prime attributes. So you can see these two non-prime attributes make these two non-prime attributes make a transitive dependency. Then when you are consider about dependency like this, what about dependencies like this? So in this case, two are non-prime, so we are going to convert this into a prime in attribute. But the case like this, in this case, prime attribute is that means prime attribute or a key attribute is depend on non-key attribute. So the condition does not violate the 3NF, yet it fails to meet the BCNF requirements. මේ වගේ අවස්ථාවකදී එයාලා 3NF වල ඉන්නවා, 3NF case එකකදී ඉන්නවා, but fail to determine the BCN. Okay, so let's discuss about so that the condition does not violate the 3NF, yet it failed to meet the BCNF requirements because BCNF requires that every determinant in the table must be a candidate key. So the situation we have just described is mostly easily understood by using this diagram. You can see in this diagram, A and B are the composite key. So this composite key determines C and D. Then this C determines B. B is a key attribute. Okay. So you can see there are no partial dependencies available in this table because these two are depend on this. So no transitive dependencies. because non-prime attributes does not depend on another non-prime attribute. So this is now in third normal form. No partial dependencies, no transitive dependencies. So this is in third normal form. Okay. But the condition is the C determine B indicate that the non-key attribute determine the part of a primary key. So this dependency is not a transitive dependency. Don't misunderstand this transitive and non-transitive dependency. So this is not a transitive. Transitive means non-prime attribute determines non-prime attribute. Okay. So in this case, non-prime attribute determines a key attribute or a part of a key. So this is not a transitive dependency. So the condition C determines B causes tables to fail to meet the BCNF requirement. So this table already in third normal form because no partial dependencies, no transitive dependencies, but this is fair 3NF BCNF requirements. So to convert this table structure into a table structure that are in 3NF and in a BCNF, first you can change the primary key A plus C in this appropriated action because the dependency C determine B means that the C is in an effect of super set of B. At this point, the table is in 1NF because it contains the partial dependencies. The next following example, you can get some idea about this one. So you can see A, B, C, this non-prime attribute determines a prime attribute. So, but this is in 3NF, but this is not in BCNF. So we need to take C as a primary key. So you can take A plus C as a primary key. At that time, you can see partial dependencies available with these two tables. So we are going to eliminate. Now this is in first normal form because there is a partial dependency of A, B, C. We are going to take this as a primary key. We are going to eliminate this from the primary key position. Then you can see A and C are get together to form the composite key. So you can see this is in first normal form because you can see there is a partial dependencies. A and C are the composite key, but part of the composite key determines one attribute. So we need to convert this partial dependencies. To convert these partial dependencies, we can create two relations by using A plus C, B. You can A plus C determines D and C determines B. Again, you can see when consider about this A, B, C. Okay, so you can see this is the primary key of this table. So this is in third normal form, but there is a relationship like this. C determines B. B is a key. Okay, you can see this is a key. So at that time you can see C attribute. That means non-prime attribute determines a part of a primary key. So this cannot be this. So this is not in a BCN form, but this is in a third normal form. So we need to convert this relation into BCN form. To convert this into a BCN form, we are going to eliminate this from the position of primary key. We can take these two as a composite key, then A, C. So you can see now C can determine B. In this case, B determines C. Now C can determine D because this is a composite key. So A and C get together to determine both B and D. Okay. Then when we consider about C determines B, you can see it's a partial dependency because this B is depend on part of the primary key, not whole primary key. So we need now this table is in 1NF or first normal form, because there is a partial dependency. If this is in second normal form, you need to eliminate all the partial dependencies. So again, we are going to eliminate the partial dependencies. To eliminate this one, we can create two relations. C determines B, one relation. C is a key, B is a non-prime attribute. This is okay. Then let's take A plus C. A plus C determines this P. Now you can see all these two relations are in BCNF form as well as third normal form, because no partial dependencies, no transitive dependencies, and also you can see no key attribute, no non-prime attribute determines the key attribute. So now you can say these two are in 3NF and BCNF. So you can see third normal form to first normal form. This is known as a denormalization. There are some cases that you need to denormalize. Denormalize your database to achieve desirable objectives. Okay. Then let's discuss this with an example. You can see a student ID, then the staff ID, class code, and the enrollment grade. These are enrollment grade. These are the available attributes in this table. So, what is the primary key of this table? Can someone identify the primary key?
Class code.
Class code.
Class code and student ID composite.
Class code and the student ID. Which one? Duplication values. No? Yeah, you can take. In this case, they only class code. You can take class code, but sometimes by using this class code, can we? Student ID plus class code. Oh yeah, you can take these two as a primary key, or in other can take. Or this is also composite key, or you can take these two fields as a primary key. Okay, that's up to you. Then in this example, they took that student ID and the student staff ID is as a composite key. So class code. So this is for represent the BCNF. No, so you can take these two as a composite key. In this example, they took these two as a composite key. So at that time, you can see this is student ID, then student ID, staff ID, class code, and the enrollment gate. Student ID and the staff ID get together to determine class code and the enrollment grade. But when we consider about this class code, you can use this class code to identify the staff ID, who is the person that going to conduct this class or anything like this. So this is non-prime attribute. This is a non-prime attribute. So you can see there are no partial dependencies available in this diagram. So this is in third normal form, but not complete the requirements for the BCNF. So you can convert this into a BCNF by taking these two as primary key. So at that time, student ID and the class code is the primary key. Then you can take the enrollment grade. Then you can take class code as a primary key and the staff ID. Now both are in 3NF as well as BCNF. Okay. Like this, you can convert your relations into BCNF if it is not in a BCNF form. Okay, do you have any other questions about this? Where's that one? Do you have any questions? Okay, I think no questions. Then let's discuss that CAT exam paper. Wait. Yes, that one. Okay, this one. Is this the question? I think this. Is this correct? This is the question you want to explain. Okay, so wait. Okay, then let's discuss this question with together. So what is the normal form of the table? What is the normal form that this table is currently in? You can see single ID, then the single name, single age, album ID, album name, album type. This is song, I think song, or song, I think song ID, then the hours. So what is the normal form this table is in? Can someone answer my question? What is the normal form? Yeah, this is in first normal form. So this is in first normal form, but there are so many dependencies. So you can see single ID and the album ID is the primary key of this. So what is the partial dependencies? You can answer this question. This is a simple, so this is a theory question. Then if there are a partial dependencies in the above diagram, identify and mark them. So can someone answer my question? Identify the partial dependencies.
First,
Wait,
single region, single.
please give me 1 second. Wait, let's discuss it by using a whiteboard. Okay. Okay. So identify the partial dependencies. Can someone wait?
Name depend on.
Okay, let's take single ID. So what are the attributes depend on this single ID?
Single name and single age.
Single name and the single age. Okay, then the next one. What is the next partial dependence?
Album ID.
Sorry, album ID.
Album ID.
Album ID. So when we consider about album ID is depend on
Album name.
Determines album name and the album types. Okay. You can mail, sorry, this is a question for the chat. This is chat question. This is the answer for the question in the chat. You can mail it into Miss Hirunika. Okay. After that, I will check it and give you the comment. Okay. Then you can see album name, album type. Okay, album type. Then there are two. So what are the other partial dependencies? There are some other partial dependencies. Only two? What are the other partial dependencies in this table? No one in the class, no.
So album ID, sender ID, and ours.
Singer ID and the album ID determines what are the attributes.
Ours.
Yeah, you can see
Singer ID, album ID.
ID determine album name, album type, sound ID, or song ID, then the hours. You can see, you can easily identify. You can see this is the singer ID. You can see there are two determinants, singer ID, singer name, and the singer name. When we consider about singer ID and the album ID together, you can see this together determines album name, album type, and the sound or sound. I think I don't know what is this song ID. I think song ID and the hours. Then when we consider about album ID, you can see album ID determines album type and the album name. Okay, these are the three partial dependencies available in this diagram. Are there any other partial dependencies? Are there any other partial dependencies? There are some other, no, okay, there are some other transitive dependencies, but only three partial dependencies. Okay, then the next one is what is the transitive dependencies? If there are any transitive dependencies in the above diagram, identify and mark them. So what is the transitive dependency?
Album name and album type.
Yeah, album name determines the album type. So it is the transitive dependency. Okay. Then normalize these three tables to confirm the, that means confirm the third normal form and BCNF. You can see this is now in first normalized form. Then you can convert this into a second normal form. Wait. I'm going to clear this one. Okay. So you can take singer ID and the singer. I'm not going to write it as a singer. This is the relation singer. You can clearly indicate, or you can use this relation schema to represent. I'm going to take relation schema, singer ID, then singer name and the singer age. This is the primary key. Then the next one is about album ID, then album name and the type. Then the next one is, which one? Singer ID and the album ID determines song ID and the hours. Okay, no? Yeah. These are the, this is album name, ID name and the type. It is impossible, difficult to write in the whiteboard. Okay. So this, now this is in second normal form. Then we are going to convert this into a third normal form. So you can see there is a transitive dependency. What is this? Album name determines album type. This type. Okay, you can see this. We can take this as a primary key. And the album name, you can see now this is in the third normal form, but it's still not in the BCNF. You can see there is another that means another dependency or a determinants is this song ID determines the album ID. Wait. Song ID, I think it's song ID. Song ID determines the album ID. This is a primary key, that's why that is show occur. So you can take album ID as, yeah, album ID, yeah, song ID. No, you can take song ID as a primary key. So you can take song ID, eliminate this album ID. After that, you can reconstruct these relations into third normal form. It is difficult writing this. So album ID, then album ID determines this one. So you can see when consider about album ID. Yeah, this is not a not album ID. You can take a song ID. Or you can take these three as a composite key. That is easy. You can take single ID, album ID, and the normal ID as a primary key. At that time, you can see. Yeah. Or you can take like this. Single ID, single name, age. Then you can take this. Yeah, song ID. No? This is album ID. Album ID determines these two. No? So you can take these three as a primary key. Then you can eliminate non-key attribute. Non-key attribute determines key attribute concept. Then it is in third normal form. So you can provide the answer like that. Okay. Are there any other questions? Are there any other questions? Okay, I think no questions. Your first, yeah, your first CAT examination is in, I think, 16th November. I'm not going to conduct. There is an extra session. No, it will be cancelled, I think. So I can cancel not sure. Most probably I'm going to cancel that session. So you can go through from this number 1 up to 13th. 13th, your first examination, CAT examination is a home assignment. So you can provide the answer within 24 hours, I think. Are there any other questions?
Excuse me, madam.